Thank you. So as in the introduction mentioned, we are basically part of a global team spanning not only two oceans, but going a little bit further. And we all are working in the same mission. The mission is basically to work with financial services customers and help them to bring their HPC workloads to the cloud, to Azure. And I'm especially dedicated working for bigger accounts in Europe, in EMEA, and since a long time part of that journey. My name is Darko Charlie, as I said. I have a background in financial services. I've been working in risk management functions in private banks, investment banking functions, and I'm very excited to be here. Bruce?
And I'm Bruce Moxon. I have a long history in high-performance computing and big data, both on the scientific side and the commercial side, in terms of HPC and a lot of large data warehousing as well. So, and I work with customers in a variety of areas, but focusing largely on scalable infrastructure for finance analytics, infrastructure as code, and I'll tell you a little bit more about that later, but how you bring large infrastructure to bear to solve problems that you probably couldn't do otherwise.
Thank you. So both of us will be co-presenting today. So I will start in the first bit. Bruce will take over in the second bit of the presentation. And but we will both be interactively here for your questions. And should you have, so please feel free to drop them in the chat window. So setting the frame for the next 30 minutes or a little bit less now. So in the first bit, we will try to set a little bit the frame about digital transformation and the bigger theme which we saw and heard in today's talks. We will focus a little bit on the challenges, in particular in the modern risk office or risk management platforms, before we spend, I think, the bigger portion of a presentation walking you through how high-performance computing is used in financial services industry. We will try to walk you through kind of back office, middle office, and front office scenario, and we will leave at the end some additional information collections which we think might be interested for you for further reading. If you touch on digital transformation and the building blocks, usually Microsoft, we are not only working in risk management, but we're touching a lot of topics like core banking, open banking, end-to-end productivity platforms, process automations, etc. But in today's talk, we will focus on two aspects: the openness and agility of scalable cloud platforms, and how computing for risk management and trading can be utilized and leveraged in that context. If we put ourselves in the shoes of a traditional risk officer, let it be credit, market risk, anything of the kind, the challenges which we see when we talk with our customers, and also myself from experience, but I'm facing just the middle bit. I have legacy system I have to deal with. Data is often fragmented. Reports are static, and especially the tools and the processes to create those reports, month-end reports, quarterly reports, etc., often semi-manual, error-prone, and it's a time-consuming process. We have a goal in supporting the digital transformation aspects to improve efficiency, improve operations, empower their employees to be more agile and free to use the tools which they want and need at the right point in time, agility and speed, again, to improve it, and at the end, empower the bank and our clients to make better risk decisions on capital calculations. And we do this by having two pillars. We help them to evolve what they already have today, and then help enable them to what we call disrupt for the new challenges which are coming. Bruce, if you, yeah. To achieve our goal, we are basically following a kind of a methodology which we called here, which you can see here depicted in the form of a matrix. We call it like a proactive and modular approach on risk management. Although the slide looks quite complicated and heavy, I'll try to walk you through in 1 or 2 minutes. The basic idea here is that we're focusing basically on the in two aspects: helping the business to evolve and do things better, which we're doing already today. It means streamlining the core risk components and embracing open and modular risk components. I will mention what I mean by that in a second, while also making them ready for future and for new challenges by enabling them for disruption and amendment of processes. What I mean by streamlining the core risk processes is basically improving today's processes in terms of efficiency, agility. This can be done by applying and leveraging cloud-based risk infrastructures, but it is a much bigger play here. We are talking about breaking down reporting silos across the different risk operations. We are talking about unifying data taxonomy, having a unified data lake, move from batch processing to real-time processing, and optimize the end-to-end risk process as in general. If you move to the right to the open and modular risk part, we have here two themes. Open in a sense to embrace collaboration with third-party providers and solutions like SaaS providers, which are providing point solutions for a specific problem, like FRTB on regulatory solutions for smaller institutions, where they can basically use a SaaS application instead of developing something on their own, but also embracing kind of a sharing idea of exchanging data, reusing data amongst consortia and other banks as well. This is part of an evolving theme on the x-axis, and if you transfer, I think, the idea a little bit more to the y-axis, we are touching grounds where we are transforming the business of the risk officers in general and trying to enable them from a kind of core functionality of guardians of a balance sheet to something where we are actively transforming the way business is done. That means applying new technologies, applying new concepts like artificial intelligence, machine learning in all aspects of risk, and combining, for instance, all three quadrants might think, and this is what we are in discussing, lead to a new approach, like providing the expertise and the services to other smaller banks, insurances, etc. And this is what we subsumize here as risk as a service ecosystems, which is kind of the holy grail or the ultimate goal of disruption, where banks are offering specified services or specific services where they have expertise to other players in the market. To achieve that, we need kind of a new generation of a risk platform. Thank you, Bruce. And the platform of the next generation has a ton of building blocks. We will touch things like external data sources. I've touched about data in terms of streaming, transactional data, making data available for the quant teams, for data scientists, for data catalogs, enabling collaboration, co-creation, surfacing the models, integrating the models in codes. All these aspects have to be covered by the next-gen risk platforms. But the core of the next-gen platform is the analytical platform, which you see here highlighted in light blue. And the certain components like the compute, like scheduling and orchestration, high-performance compute, distributed engines, high-performance aggregation engines, CI/CD pipelines, containers, training, etc. All these are components which are kind of the core ingredient in the topics which we would like to focus in the remaining minutes. Bruce, if you could click to the next slide, please.
You should be there.
Thank you. So, after having set in the frame, let us focus a little bit more on the examples and dive deeper in the project engagements and some architecture discussions what we're seeing with our customers. We are focusing here in this picture basically on the risk compute part of what we have seen in the slides before. And I will walk you here in this slide basically from a front to back process, or kind of from a risk perspective, trading perspective. This is a simplified picture. I'm sure there are details which we could add to that slide, but for clarity, I've kept it on that level. And what we see kind of from a traditional maturity level and how our customers have started embracing the cloud for agility and utilizing leverage compute on Azure, we usually start with the middle and back office view, which is often motivated by overnight jobs for regulatory workloads, where the Basel numbers, where things like XVAs, the FRTD, the fundamental review of the trading book regulations are computed in an overnight manner, in a batch processing way. And this is kind of, from a maturity level, often the starting point our customers start and embrace the journey to the cloud. While gaining experience and also driven by the front office and back office tools which we are using and leveraging, this approach tends to shift a little bit, especially in the times of highly volatile markets, with overnight processing jobs are often not enough to represent the risk and the measurements and the counter measurements the bank would like to see intraday. So the overnight batches are often calculated once, twice, even multiple times throughout the day, and the architectures evolve slightly in the sense that the transformation from an overnight batch processing way makes room for intraday risk calculation type of views. Evolving further and also further growing with the maturity level, the front office tasks and expert calculations go to the front office decision as well, and they don't stop there. We see the adjustment and the implication of cloud already in the trade execution, trading signals, high frequency trading parts way before the trading decisions happen. If you just focus a little bit more on the back office view and the traditional batch view of often uncoupled and embarrassingly parallel Monte Carlo calculations, we will, this is the perfect point to transition to the next slide and to the next speaker. Thank you, Bruce.
Thanks, Darko. Sound okay?
Yeah.
Good. So I'm going to start where Darko left off, which is leaving us with some of what has been going on and what continues to go on in terms of leveraging high performance computing, accelerated computing approaches for the back office, right? So these are largely today the batch overnight opportunities, and to touching back on the evolve and disrupt, you can sort of think of this as more the evolve phase, right? So many of the financial services institutions, certainly the largest ones, have been doing large-scale cluster computing, large-scale Monte Carlo analysis for many years. They haven't necessarily been doing them in the cloud, but a lot of them the last few years have been moving that way as a means of doing things more efficiently and in a more agile manner. And I tend to talk about bringing DevOps to high performance computing or high throughput computing. Traditionally, HPC deployments were based on multiple constituencies within an organization. This would be in finance, or it could be in more technical application areas. You go through a process of collective requirements, architecture definition, run a bunch of benchmarks and POCs, put together a formal procurement, and then lay down a bunch of money for a 3 to 5 year lifetime investment, perhaps with some rolling technology refresh. You kind of hope you got your applications and benchmarks right, at least as being indicative of what you were going to be doing for the next 3 to 5 years. In the cloud world, a lot of those constraints sort of go away, right? I mean, there's some other challenges, obviously, but things like being able to leverage new server architectures day one, like high bandwidth memory machines or new versions of GPUs or FPGAs as they roll out. And being able to do this not only from a development perspective, but also once validated to be able to roll those out at scale is an opportunity that you just don't have on-prem. So you can do sort of rapid, I'll call it, I tend to call it campaign analytics, right? You don't have to think of departmental high performance computing. You can sort of think of it in a campaign perspective where you've got a business owner in a need who may have a 3-month duration project to go explore some new analytic approach and wants to fire up some new infrastructure that either they don't have in-house or they don't have much of in-house, or it's completely tied up in production computing workloads. They can do that in the cloud. They can experiment, they can test scale, and they can then proceed with deployment. And scaling up and down as needs require. This does echo a little bit of the excuse me, no code, low code discussion. The prior speaker, although here we're talking about specifically low code in large scale infrastructure deployment, and we use infrastructure as code mechanisms here to be able to scale up to 100,000s of cores literally in a few minutes, run them for 2 or 3 hours, and scale them back down to 0. And this is something that you just don't have in most on-prem environments. Even if you have the resources, a lot of those resources are tied up in existing production workloads. So one of the things that we work on, a lot of the applications in finance tend to be data parallel, or some people call them embarrassingly parallel, but ones where you want to be launching tens of thousands, hundreds of thousands, or millions of tasks to do Monte Carlo analysis and various parameter explorations. And Microsoft has a very nice facility called Azure Batch for that we've been working on specifically with the financial services industry to craft a platform for rapid deployment of financial services modeling applications. They can use CPU, they can use big memory, they can use GPU, they can use FPGA. So it really depends on the specifics of the analytics campaign you're embarking on. Pretty much any language, and again, infrastructure can be deployed at large scale very, very quickly in literally orders of minutes to bring up tens of thousands of cores. We're seeing real-time portfolio risk analysis, backtesting, market data analytics, and finance. There are other application areas where the same model is well represented. And so we continue to see development of approaches which, again, get you to the low-code scenario of being able to deploy an application, scale it to very large configurations, and then drop it down to nothing once the results are in. I was alluding to something that I've been working on. One of my colleagues started called Azthinsim, which is this batch architecture. If you look in the middle, conceptually you have a pool of VMs which scale on demand, so they're not always running. They basically scale up as needed. They are dispatched using the Azure Batch platform. So you think of this as a job and task scheduler, which is involved in this case, pulling data from a container registry, dropping it onto the VM, executing a set of tasks on that VM, and then basically circling back and getting the next task out of the queue for that same container. So the container might be deployed for the entire computation, might be multiple hours, but the individual tasks or jobs are basically cycled through that pool on a much more granular nature. And then in this case, we've got, there are a number of opportunities for data input and output. We've run some examples that are sort of low data footprint with Redis cache. There are larger data footprint operations with scalable file systems that we also work with. And then It also uses Azure monitoring for tracking and performance telemetry. So a fairly, a quite robust environment for a lot of applications that fit into this model, and in an infrastructure as code, build, deploy, and run model. Darko mentioned sort of front office intraday, middle office intraday, and back office views. I'm going to focus a little bit now on a couple of the things that he mentioned, where customers are starting to take some of those approaches now that they can do dynamic scaling and build up very, very large compute infrastructure and tear it down, effectively almost immediately. They're looking at applying some of those into intraday. So if you can fire up enough cores to do what you typically would run in a Monte Carlo in 3 or 4 hours and overnight, but you can fire up more cores and run it in 15 minutes. How does that change what you're doing from a trading perspective? And that's some of what we look at as well. There's an example here of an interactive pricer. Is sort of one of the examples that we use. If you look generally at these types of architectures, as you move from sort of more the batch on the back office side to more interactive on the front office or the intraday, these tend to look a little bit more like sort of streaming big data architectures, right? You sort of think of streaming data coming in. You have a large data repository, historical data that's been used for some of your back office analysis, testing, training, et cetera. And now you want to be able to leverage that in conjunction with the data as it's coming in sort of the front end. And so you sort of match this batch layer with a speed or interactive layer that are tied together in some of those resources and leverage the same capabilities of auto scaling and rapid scale up, scale down. And you can now start to build services into your environment that look more like an interactive pricing environment. So I'd mentioned the big data like view of things, which this shows. And the interactive pricer now becomes a tool that one can deploy that leverages a combination of the sort of large-scale batch-oriented historical data, training on it, et cetera, coupled with the real-time nature of changes in the market for much more agile and responsive real-time pricing. And Darko, if you want to chime in with comments on here, I'm more than happy, or I'll keep going and we'll do them at the end. If we, go ahead.
No, please go ahead.
If we go the next step, so the intraday is about leveraging real-time data feeds coupled with some of the large-scale computing that you've already been doing in the back office, or the approaches that you have been. If we look more to the front office, this is where you're starting to see a lot of new technologies in terms of ML/AI in particular. You're still looking at some very high performance computing scenarios. Some of it's in doing near real-time training and retraining of models, as well as inference, obviously. But you're pushing some of that infrastructure and specialized processing in GPUs and FPGAs in particular into applications that are much more responsive on the front end for immediate actions. And so this is, whether you're augmenting traditional risk models on the back end, you're disrupting a set of new capabilities with AI-driven platforms for real-time inferencing. To accelerate trading decisions, there is a need for effectively large infrastructure and overall speed. One of the areas that we've been working, this was actually some work that was done with RiskFuel, is looking at taking neural networks as an alternative to traditional Monte Carlo calculations. So you basically train, can train the models on effectively the results of large-scale Monte Carlo analyses and get to a point where the real-time inference using those models can actually buy you, in the case that they looked at, a 20,000 times faster effectively valuation pricing model that they can use. So these are some of the areas where you're seeing, again, this is more front office where you're not necessarily constrained by some of the regulatory requirements as historically have been on back end, but you're actually using this to augment your capabilities and your insights and your responsiveness to market changes more in the front office arena. And from a Microsoft perspective, we're active in a bunch of those areas. Microsoft has a very robust Azure ML kind of ML ops environment. We also do a lot of work in Microsoft Research. In particular, this is pointing to something called Qlib, which is an AI-oriented quantitative investment platform that's being used, again, to drive some of these new applications and new insights that leverage a combination of the historical data and are responsive to real-time market changes using things like reinforcement learning and approaches such as that. And I think the bottom line that some of these approaches are trying to deal with is how can you shorten the time to a model being effective for prediction, right? So you think about this sort of cycle of training and retraining models as the data changes, and then being able to predict your pricing for decision support or for action purposes. And the faster you can do that, the more insight you've got from a time to profit that you can leverage. So in other words, you're making your predictive decisions earlier. You have more time to act to take advantage of the market trends. And I didn't know if you wanted to make a couple other comments, Darko, on that, on some of the back end material. I know you work more closely with customers on some of these issues every day, and I think see some of their pain points. We do have some pointers to additional material for some of this, and there's actually a set of use cases that we also have online in terms of some of the work we've done, and the Risk Fuel reference that I mentioned earlier is also available. Do you have other thoughts, Darko?
If you go back just, so first of all, thank you, Bruce, for walking us in for the second part. I think the main thing I'd like to add here is we are really moving to a close to real-time, near-time environment in risk management. Not only in the areas of trading, which we are seeing here, and participating in market movement, but also really monitoring and going and steering through the crisis. So the architectures and the developments which we are seeing are gearing really towards that, making data available continuously throughout the trading day, monitoring risk throughout the trading day. And based on those initiatives, and also motivated what happened in the past year, we see that customers, especially in larger investment banks, are taking up the momentum to review the architectures, how they can not only satisfy kind of considerations in terms of risk aspects and in risk management and monitoring, but also participate in this highly volatile markets and make successful trading. Not only in trading, asset management, wealth management. I think all these investments are being made now, and we are supporting them, basically leveraging technologies like GPUs, CPUs, etc., in the architectures to achieve it. Basically, I think it's a general trend which is happening, and I think similarities in architectures, which you have described, Bruce, with on the big data side, Lambda, Kappa, however we will call him. I think there is a theme. This is something emerging also in the risk compute world. I just like to close just with that comment here.
Yeah, and I think just to add, I think our focus really is on bringing a plethora of technologies together in a way that makes sense for our customers to be able to leverage, again, sort of the state of the art in large data, big compute scenarios for some of these really kind of disruptive